Hello, in this lecture we'll find out the area of the orange shape using two different methods. In the drawing we have square ABCD. You know that one side of square ABCD equals to 10 units. Inside square ABCD we have two semicircles, the semicircle DPC and the semicircle APQ. They intersect with each other and they create the blue lens. The blue lens is the common area that belongs to both semicircles. In addition, we have the quarter circle ABQD. This quarter circle intersects with the semicircle CPD and they create the blue lens, the big lens. The big lens is the common area that belongs to both to the quarter circle and to this semicircle. And our mission is to find out the area of this orange shape. So actually the area of this orange shape equals to the area of the big lens minus the area of the blue lens. Okay, so I write it down. The area of the orange shape equals to the area of the big lens. This is the big lens minus the area of the blue lens. This is the blue lens. So I will repeat again that the area of the orange shape equals to the area of the big lens minus the area of the blue lens. I will repeat again that a lens is the common area that is created by the intersection of two shapes. Here, the big lens was created by the intersection of a quarter circle with this semicircle, and the blue lens was created by the intersection of those two semicircles with each other. This semicircle and this semicircle create this blue lens. Okay, so we'll solve this question in two different methods. In the first method, so here we know that the two semicircles perpendicular to each other, they are perpendicular to each other. This angle equals 90 degrees, and also the quarter circle is perpendicular to this semicircle. That is to say, this side of the quarter circle create with this side of the semicircle angle of 90 degrees. So both shapes, both lines were created by two shapes that are perpendicular to each other. So we will create a formula that is the area of two lenses that are perpendicular to each other, and we'll use the formula in order to find out the area of the blue lens. We can use the formula to find out the area of the blue lens because the blue lens was created by the intersection of those two semicircles that are perpendicular to each other, and we also can use the same formula in order to find out the area of the big lens that was created by the intersection of this quarter circle that is perpendicular to this semicircle. Okay? So, and while in the second method, we'll find directly the area of the big lens, and we'll find directly the area of the blue lens. We'll subtract the two areas from each other, and this will give us the area of this orange shape. Okay, so, but first of all, I'll clarify two concepts here. What is the area of this sector, the area of the green sector? It is equal to the ratio between angle theta and 2 pi radians. 2 pi radians is 360 degrees. So here, that ratio theta over 2 pi gives us the relative percentage that this sector occupy out of the area of the entire circle, and when we will multiply the percentage by the area of the entire circle, we get exactly the area of this green sector. Okay, so the amount of percentage that this sector occupy out of the area of the entire circle times the area of the entire circle will give us exactly the area of this sector. So this is the first concept. And the second concept is the area of this green shape that is defined as circular segment. Okay? The area of this circular segment equals to the area of sector AOB minus the area of triangle AOB. Again, the area of sector AOB minus the area of triangle AOB gives us the area of this green shape that is the circular segment AB. Okay? So here in the first method, we will take those two circular segments that are perpendicular to each other, exactly like in the original drawing. The two semicircles are perpendicular to each other, and this is the lens that was created by the intersection of those two semicircles that are perpendicular to each other, and we can use the formula that we will create also in order to find out the area of the big lens, because the area of the big lens was created by the quarter circle that is perpendicular to the semicircle. Okay? So here we will define the radius of this semicircle as A. The center of this semicircle is at point O, and this is point M. Point O is the center of this semicircle, while point M is the point on the semicircle itself. Therefore, OM is the radius of this semicircle that is equal to A units, according to our definition. So, as I already mentioned before, we have the quarter circle that intersects with this semicircle, and the radius of this quarter circle equals to 10 units. So here, if A equals to 10 units, then it will be like the quarter circle that intersects with the semicircle with the angle of 90 degrees. So we can use the formula that we create in order to find out the area of this big lens. And of course we can use also the same formula in order to find out the area of the blue lens that was created by the two semicircles that intersect with each other, and they are also perpendicular to each other. So here we define the center of this semicircle as point N. Point N is the center of this semicircle. Point M is the point on this semicircle itself, so Mn is the radius of this semicircle. We define the radius of this semicircle as B. Here this point is L, so point N is the center of the semicircle, point L is the point on this semicircle itself, therefore NL is also the radius of this semicircle, that is equal to B units according to our definition. And here point O is the center of this semicircle, point L is the point on this semicircle itself, therefore OL is the radius of this semicircle, that is equal to A units according to our definition. Okay, so here we draw the radius OL in such a way that is tangent to this semicircle as point L. So point L is the point of tendency of tangent OL with this semicircle. So here we have the radius NL of this semicircle that is drawn to the point of tendency. That is to say, it is drawn to point L, that is the point of tendency of tangent OL with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent OL will be perpendicular to the radius Ln. So if OL is perpendicular to OL, it means that this angle equals to 90 degrees. In the next step, we join points M and L together by a straight line. By joining points L and M together by a straight line, we divided this length into two parts. We'll calculate the area of each part. We'll add the two areas together, and this will give us the area of this length. That could be the blue length, and it also could be the big length. So this is the upper circular segment of this length. In the next step, we'll join points N and O together by a straight line. So, what is the area of this circular segment, the upper circular segment? The area of the upper circular segment of this length it is equal to the area of sector MOL minus the area of triangle MOL. So it is equal to the area of sector MOL this is sector MOL minus the area of triangle MOL. Minus the area of this triangle MOL. It is very easy to see from the drawing if you subtract the area of this triangle MOL from the area of this sector MOL, you will get exactly the area of the upper circular segment ML. So this is the circular segment ML. This is sector MON. This is triangle MOL. In order to find out the area of sector MOL, we have to find out the size of this angle MOL. Okay, so here we define angle MOM as theta. Here triangle NMO, this triangle and triangle NNO, those two triangles can go into each other according to side rule. We'll explain why. Here, those two sides, they are both equal to A, therefore they are equal to each other. In addition, those two sides, they are both equal to B, therefore they are equal to each other. And finally, side ON is a common side that belongs to both triangles, therefore this side equals to itself. So we actually found out that those two triangles can go into each other according to side rule, and from the fact that those two triangles can go into each other, we conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So if those two angles are equal to each other, it means that if this angle equals to theta, then this angle must be also equal to theta because of the fact that they are equal to each other. So this angle equals to theta, so in conclusion, we found out that the size of angle MOL is theta plus theta, that is 2 theta. So this angle equals to 2 theta. MO equals to A, OL equals to A, so the area of sector MOL will be equal to the angle between the legs of sector MOL is 2 theta over the angle that is equal to 2 pi radians, that is 360 degrees, times the area of this circle, that is pi r squared, and r equals to a, so it is pi a squared. Here we have pi in the numerator and pi in the denominator, so pi will get cancelled. We have here 2 in the numerator and 2 in the denominator, so 2 also will get cancelled. And in conclusion, we found out that the area of sector MOL, this sector, equals to theta times a squared. Now we have to subtract the area of triangle MOL from the area of sector MOL that is equal to theta a squared. So here we have to subtract the area of this triangle MOL. Okay, we'll do it later. So in the next step, we'll find out the area of the lower circular segment. In conclusion, we found out that the area of the upper circular segment equals to theta e squared minus the area of triangle MOL. So in the next step, we'll find out the area of the lower circular segment ML. Okay, the area of this. Here I must emphasize that the two areas are not necessarily equal to each other. The green shape is not necessarily equal to the orange shape. Why? Because of the fact that A and B are two radii that could be equal to each other, but A is not necessarily equal to B, therefore those two areas, they are not necessarily equal to each other. So we have to find out the area of each part separately. Okay, if the two radii they are equal to each other, then those two circular segments will have to equal to each other too, but here A and B are might be two different numbers, therefore they are not equal to each other, and therefore those two areas are not equal to each other, are not necessarily equal to each other. So what is the area of the lower circular segment, the orange shape? The area of the lower circular segment, MN, as I've already mentioned, this lens could be also the big lens. And we know for sure that in the big lens, the radius of the quarter circle equals to 10, while the radius of the semicircle equals to 5. So you can see that A is not equal to B, therefore those two areas will not also be equal to each other. So what is the area of the orange circular segment? The area of the orange circular segment will be equal to the area of sector M and N, the area of this sector, so this is sector M and N. This is circular segment MNL. Circular segment ML, of course. So, minus the area of triangle MNL. This is triangle MNL. Okay, the area of the sector minus the area of triangle MNL will give us the area of circular segment ML. It is very simple, very easy to see it from the drawing that if you subtract the area of triangle MNL from the area of sector MNL, you will get exactly the area of circular segment ML. Now we have to find out the value of angle MNL, that is the angle that is between the legs of sector MNL. So here, this angle equals to theta, this angle equals to 90 degrees, so in the right triangle OMN, this angle must be equal to 90 degrees minus theta, or in terms of numbers, is pi over 2 minus theta. Because pi over 2 radians is 90 degrees in terms of radians. Okay, so the same thing is true here in the right triangle ONL. This angle equals to theta, this angle equals to 90 degrees or pi over 2, therefore this angle will be equal to pi over 2 minus theta. Okay, so what is the size of angle MNL? The size of angle MNL equals to the sum of those two angles. It is equal to pi over 2 minus theta plus pi over 2 minus theta. Pi over 2 plus pi over 2 is pi, and minus theta plus minus theta is minus 2 theta. So in conclusion, we found out that the size of this angle M and L, equals to pi minus 2 theta. Okay. So here, this angle equals to pi minus 2 theta. Mn is B, and L also B. So the area of sector M and N equals to pi minus 2 theta over 2 pi radians, that is 360 degrees in terms of degrees, times the area of the circle, that is pi r squared, but r equals to b, so it is pi b squared. This is the area of this circle that sector M and L is part of that circle. So here we have pi in the numerator and pi in the denominator, so pi will get cancelled. Now we will open the brackets here. So here we get pi b squared over 2. And here it is minus 2 theta times b squared over 2. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So in conclusion, the area of sector M and L, the area of this sector, equals to pi times b squared over 2 minus theta times b squared, and we have to subtract from the area of sector M and L the area of triangle M and L. So it is minus the area of this triangle, triangle M and L. Okay? And we know that the area of this lens, that could be the orange, the blue lens or the big lens. The area of this lens equals to the area of the upper circular segment plus the area of the lower circular segment. So we will add the two areas together and we get the area of this lens. Okay? So the area of this lens equals to the area of the upper circular segment, the green upper circular segment, plus the area of the lower orange circular segment. Okay? We have already found out that the area of the upper circular segment, the green shade, equals to the area of sector M O L minus the area of triangle M O L plus the area of sector M and L this is sector M and L minus the area of triangle M and L. And this is equal to, actually, to the sum of the two sectors. The sum of the areas of the two sectors MOL and sector M and L minus the sum of the areas of those two triangles. Okay? Triangle MOL plus the triangle MNL. And we have already found out that the area of sector MOL equals to theta times A squared, while the area of sector MML equals to pi B squared over 2 minus theta B squared. So this expression, it is actually equals to the sum of the areas of the two sectors, and we have to subtract from this expression the sum of the areas of those two triangles. So our mission is to find out the areas of those two triangles. In order to find out the areas of the two triangles here, we'll combine them together and we will create quadrilateral. Okay. Combined the two circles together. You know that this angle equals to 90 degrees, and this angle also equals to 90 degrees. MO equals to A, OL equals to A also, MN equals to B, and NL equals also to B. In the next step, we'll join points N and O together by a straight line. By joining points N and O by a straight line, we created two right triangles. And it is very easy to find out the area of each right triangle. The green right triangle N, O, and L. O, M, L, O, M, N. This green right triangle. And the orange right triangle, OLN. The area of the right triangle equals to the base of the triangle, that is B, times the height of the base, that is A, over 2. While the area of the orange right triangle equals to the base of the triangle, that is A, times the height of the base, that is B, over 2. So BA and AB are equal to each other, of course, so BA plus AB is 2AB, so it is 2AB over 2. We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So in conclusion, we found out that the sum of the areas of those two right triangles, it is equal to AB, and this is exactly the sum of the areas of those two right triangles. So the sum of the areas of those two right triangles is equal to AB. So in conclusion, we have to subtract AB from this expression, and this will be the area of this length. That could be the blue length, or it could be also the big length. Okay, so I'll write again the formula for the area of this sector in a new page. So actually, the area of length, this length that could be the blue length or the big length, Actually, the formula that we found out is good only for the area of the big lens and the blue lens, and not for any other lenses, because all the lenses that were created by two shapes that doesn't perpendicular to each other, it will not be good for all those lenses. They are good only for two lenses that were created by two shapes that are perpendicular to each other. Exactly like in our drawing. Okay? So we can use the formula in order to find out the area of the big lens and in order to find out the area of the blue lens. So here we found out that theta times a square plus pi b square over 2 minus theta b square, and we have to subtract from it AB, that is the sum of the areas of the two triangles, minus AB. Okay, that is the area of this lens that could be the big lens or the blue lens. Okay, so here we take theta as a common factor out of these two expressions. So what left from this expression after we took from it theta as a common factor? What is left, it is actually a square. And what is left from this expression after we took from it theta as a common factor? What is left, it is actually minus b square. And we have to add to this expression pi b square over 2. And to subtract AB. So this is the formula for the area of the blue lens on the area and the area of the big lens. Okay, but we want to eliminate theta here because we want a formula that the only missing variable are A and B, that are the radii of the two shapes that intersect with each other. In order to find out the value of theta, I will draw the right triangle OMN that contains angle theta. OM equals to A units in its length, MN equals to B units in its length, and the angle that we are looking for, angle MON, is angle theta. So in the right triangle, triangle OMN, tangent theta equals to mn over mo. Here mn equals to b, mo equals to a. So in conclusion, I found out that tangent theta equals to b over a. But we are not interested in tangent theta, but in theta itself. In order to get theta itself, we'll operate the opposite function of tangents on the result, that is b over a. In this way, we get the value of theta itself. So here we get that the value of angle theta itself that we are looking for, it is equal to tangents minus 1, that is the opposite function of tangents. We will operate it on the result, that is b over a, and this will give us the value of theta itself. So we found out the value of theta itself. Now we can substitute theta in this formula by tangents minus 1 of b over a. Okay. So we get that the formula for a lens that could be the blue lens or the big lens and any other lenses that were created by two shapes that are perpendicular to each other. So it is the area of this lens equals to theta is tangents minus 1 of b over a times a square minus b square plus pi b square over 2 minus ab. Okay. Actually, I found here a formula for the area of any lens that was created by two shapes that are perpendicular to each other. That is to say, we can use this formula in order to find out the area of this blue lens that was created by the intersection of those two semicircles that are perpendicular to each other, and we can use the same formula in order to find out the area of the big lens that is also always created by the quarter circle that intersects with this semicircle, and they are also perpendicular to each other. Okay? Any two shapes that are perpendicular to each other and created a lens, this formula, we can use it for finding out that lens. Okay, so in the first step, we will find out the area of the big lens. So the area of the big lens this lens is created by the intersection of the quarter circle with this semicircle. It is very easy to see that the radius of the quarter circle equals to 5 units. So A equals to 5, to 10 units, equals to 10. Here the radius of the quarter circle equals to 10 units. And the radius of this semicircle that intersects with the quarter circle, what is the radius of the semicircle? We know that the diameter of this quarter circle, it is obvious that it is equal to 10 units. Therefore, the radius must be equal to 5. Okay? So here we know that A equals to 10, B equals to 5, so we'll put the values of A and B inside this formula, and this will give us the area of the big lens. So here we get that tangents minus 1 of B is 5, A is 10, so 5 over 10 is 1 half. 1 half is 0.5 times A squared minus B squared. A is 10 and B is 5, so A squared minus B squared is 10 squared minus 5 squared. Plus pi, B is 5, so B squared is 5 squared over 2 minus A is 10 and B is 5, so it is minus 10 times 5. Okay. And we found out that the area of the big lens equals to tangents minus 1 of 0.5. Here 10 squared is 100, minus 5 squared is 25. 100 minus 25 is 75. So it is 75 times tangents minus 1 of 0.5 plus here 5 squared is 25, 25 over 2 is 12.5. So in total this expression equals to 12.5 pi. Minus 10 times 5 is minus 50. So that's we found out the area of the big lens. Okay. It is equal to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50 square units. In the next step, we'll find out the area of the blue lens, and then we'll subtract the areas from each other, and this will give us the area of this orange shape. So the area of the blue lens, I want you that the blue lens was created by the two semicircles that intersect with each other at 90 degrees. They are perpendicular also to each other. So here, and we know that the radius of each semicircle equals to 5. So here A equals to 5 and B equals to 5. So the area of the blue lens will be equal to tangents minus 1 of B over A. B is 5, A is 5 over 5 is 1. times a square minus b square. A is 5, so a square is 5 square, minus b square. B is 5, so b square is 5 square. 5 square minus 5 square is 0, therefore this expression will be equal to 0. And we have to add to this expression pi b square. B is 5, so pi b square is pi times 5 square over 2 minus AB. A is 5, B is 5, so 5 times 5 is 25, so it is minus 25. So in conclusion, we found out that the area of the blue lens, this expression equals to 0. This expression is 5 square is 25, 25 over 2 is 12.5. So this expression in total equals to 12.5 pi minus 25. That is to say, the area of the blue lens equals to 12.5 pi minus 25. Okay. So we found out the area of the big lens, we found out the area of the blue lens. Now we'll subtract the two areas from each other, and this will give us the area of the orange shape. Okay, so here the area of the orange shape equals to the area of the big lens. Here, the area of the orange shape equals to the area of the big lens minus the area of the blue lens. The area of the big lens minus the area of the blue lens. So the area of the orange shape equals to the area of the big lens. We have already found out that the area of the big lens equals to 75 times tangent minus 1 of 0.5 plus 12.5 pi minus 50, and we have to subtract from the area of the big lens, from this expression, the area of the blue lens. And we have already found out that the area of the blue lens equals to 12.5 pi minus 25. So here we'll open the brackets and we get that the area of the orange shape that we are looking for, it is equal to 75 times tangent minus 1 of 0.5 plus 12.5 pi minus 50. Here we'll open the brackets and we get this is minus 12.5 pi. Minus is minus is plus, so it is minus 25, this is plus 25. Okay. So here we have 12.5 pi, minus 12.5 pi is 0, so those two expressions will get cancelled, and we have minus 50 plus 25 is minus 25. So in conclusion, we found out that the area of the orange shape equals to 75 times tangent minus 1 of 0.5 minus 25. And we know that tangents minus 1 of 0.5 is equal to 0.46. So we substitute tangents minus 1 0.5 by 0.46 and we get that the area of the orange shape equals to 75 times tangents minus 1 of 0.5 is 0.46. Yeah. So it is 0.46 minus 25. And 75 times 0.46 is 34.77 minus 25, 34.77 minus 25 equals to 9.77. So we found out that the area of the orange shape equals to 9.77 square units according to the first method. Okay, so here the area of this green shape and the area of this orange shape, QPD, equals to 9.77 square units. So finished with the first method. In the next step I present to you how to find out the area of this orange shape according to the second method. Using the second method. In the second method, we directly calculate the area of the blue shape, then we directly calculate the area of this big lens, again we calculate the area of the blue lens, then we calculate the area of the big lens, we will subtract the two areas from each other and this will give us the area of this orange shape. Okay, we will not use a general formula, but we will calculate the areas directly. Okay. So here actually can use first of all we find out the area of this blue shape and this blue lens, and this blue lens was created by the intersections of those two semicircles with each other. So actually if we can use this drawing from the first method, because we have here two semicircles that are perpendicular to each other, they intersect with each other, and in this way they created this lens, and here those two, in the original drawing, those two semicircles intersect with each other, they are perpendicular to each other, in this way they created this blue lens. Okay, here those two semicircles are also perpendicular to each other, so this will be the blue lens that we are looking for. And here, if A equals to 5 units and B equals to 5 units, this will be exactly the drawing that is good for our purpose, to find out the area of this blue lens, because each radii of the two semicircles are equal to 5 units. Again, if A equals to 5 and B equals to 5, then this lens is the blue lens. Why? Because here we know that the radius of this semicircle is 5 units, and the radius of this semicircle, it is also 5 units. And define the center of this semicircle as O. This is point L, this is point M, this is point N. We know that those two semicircles are perpendicular to each other, that is to say, this angle equals to 90 degrees. We can see it from the drawing, from the original drawing, that the two semicircles are perpendicular to each other. Okay, and we also know that the radius of each semicircle equals to 5 units. Here the center is at point O, point L is the point of the semicircle itself, therefore OL is the radius of this semicircle, that is to say it is equal to 5 units. Point O is the center of this semicircle. Point N is the point on the semicircle itself, that is to say ON is the radius of this semicircle, that is equal to 5 units. Likewise, point M is the center of this semicircle. Point N is the point on the semicircle itself. This is exactly the definition of a radius, so Mn also equals to 5 units, and here M is the center of the semicircle, N is the point of the semicircle itself, therefore Mn is the radius of this semicircle, that is equal also to 5 units. And because of the fact that the two radii of those two semicircles are equal to each other, it means that if we draw the radius in such a way that it will be perpendicular to the diameter of this semicircle, that is to say, if this angle equals to 90 degrees, and this angle also equals to 90 degrees, then because of the fact that the two semicircles are identical, then the radius that we draw from the center of this semicircle, and it is also perpendicular to the diameter, it will be also tangent to this semicircle at point L. So here point L is the point of tendency, of tangent OL with this semicircle. So here we have the radius ML of this semicircle that is drawn to the point of tendency. That is to say, it is drawn to point L, that is the point of tendency of tangent OL with this semicircle. And whenever we have a radius that is drawn to the point of tendency, then tangent OL will be perpendicular to the radius LM. So if OL is perpendicular to LM, it means that this angle equals to 90 degrees. So this angle will be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. If three angles are right angles, then the fourth angle will be also equal to 90 degrees. So this is square ONML. So here we join points N and L together, N and L together by a straight line. and here we divided the blue length into two equal parts. Those two circular segments are identical, they have the same area, so we find out the area of the upper circular segment. Actually, it is very easy to see that those two circular segments are identical because of the fact that here sector NOL is a quarter circle because this angle equals to 90 degrees, and also sector NML, this sector is also a quarter circle with radius of 5 units. So those two quarter circles are identical. They both have 5 radius that is equal to 5 units. So we will just calculate the area of this circular segment. We will multiply it by 2, and this will give us the area of this blue lens. Okay, so here our mission is to find out the area of the blue lens. Okay. This is actually the blue lens. So we multiply the area of circular segment NL by 2, and this way we get the area of this blue lens. So first of all, we'll find out the area of circular segment NL. What is the area of circular segment NL? The area of circular segment NL equals to the area of sector NOL, the area of this sector, this is sector NOL, this is circular segment NL, so it is equal to the area of sector NOL minus the area of triangle NOL. Minus the area of triangle NOL. We know that triangle NOL is a right triangle, therefore it is very easy to find out the area of this triangle. And we also know that NO equals to OL equals to 5 units. This angle equals to 90 degrees. This angle also equals to 90 degrees. NO equals to OL equals to 5 units. So the area of sector NOL, actually because of the fact that angle NOL equals to 90 degrees, it means that sector NOL is a quarter circle. Okay, sector NOL is a quarter circle, therefore we know that the area of any quarter circle equals to the area of the circle that is pi r square over 4. R equals to 5, so it is pi times 5 square over 4 minus the area of the right triangle NOL. The area of the right triangle NOL is the base of the triangle that is 5 times the height of the base that is also 5 divided by 2. So actually this expression equals to the area of circular segment NN. We will multiply it by 2 and we will get the area of the blue lens. Because of the fact that the radii of the two semicircles are equal to each other, they are equal to 5, then the other circular segment will be identical to this circular segment. That is to say, they both have the same areas. So if we multiply the area of this circular segment by 2, we'll get the area of the blue lens. So the area of the blue lens is equal to 5 square is 25. So it is, we will multiply by 2 this area, the area of circular segment NL, and we will get the area of the blue lens. So it is 2 times 25 pi over 4 minus 2 times 5 times 5 over 2. So here we have 2 in the numerator and 2 in the and 4 in the denominator, so we divide both the numerator and the denominator by 2, and we get that in the numerator we left only with 25 pi, and in the denominator we have 4 over 2 is 2. Minus, here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. 5 times 5 is 25. So in conclusion, we found out that 25 over 2 is 12.5 pi and 12.5, and this expression in total equals to 12.5 pi. So the area of the blue lens equals to 12.5 pi minus 25. It is actually the same result as we got in the first method. Okay, so in conclusion, we found out that the area of the blue lens, according to the second method, equals to the area of the blue lens according to the first method. That is actually equals to 12.5 pi minus 25 square units. Okay, so in the next step we'll find out the area of the big lens. Okay, and as I've already mentioned before, the big lens was created by the intersection of the quarter circle with this semicircle. Here it is the intersection of this quarter circle with this semicircle. Here the radius of the semicircle is 10 units. We also know that the quarter circle is perpendicular to the semicircle, that is to say this angle equals to 90 degrees. So this angle equals to 90 degrees. We'll define this point as point O. we define the center of the semicircle as M. This is point L. Point L is the point of tendency of tangent ML with this quarter circle. So point M is the center of the semicircle. Point L is the point of the semicircle itself. Therefore, ML is the radius of this semicircle that is equal to 5 units. Point M is the center of this semicircle. Point O is the point on the semicircle itself. That is to say, MO is the radius of this semicircle that is equal to 5 units. Here we will join the two centers together by a straight line. This is point N. Here point N is the center of the quarter circle. Point L is the point on the quarter circle itself. That is to say, NL is the radius of this quarter circle that is equal to 10 units. So here we have the radius NL that is drawn to the point of tendency. The radius NL of the quarter circle that is drawn to the point of tendency, that is to say it is drawn to point L, that is the point of tendency of tangent ML with this quarter circle. And whenever you have a radius that is drawn to the point of tendency, then tangent ML will be perpendicular to the radius Ln. So if ML is perpendicular to Ln, it means that this angle equals to 90 degrees. So actually, those two triangles can connect to each other according to side rule. Triangle OMN can go to triangle NML according to side rule. So explain why they can go into each other. First of all, those two sides, they are both equal to 10, therefore they are equal to each other. In addition, those two sides, they are both equal to 5, therefore they are equal to each other. And finally, NM is the common side that belongs to both triangles, so this side equals to itself. So actually we found out that those two triangles can go into each other according to side rule. And from the fact that they can go into each other, we derive that those two angles are equal to each other according to the rule that corresponding sides, the corresponding angles that can go into triangles are equal to each other. So if this angle equals to theta according to our definition, then this angle must be also equal to theta because of the fact that those two angles are equal to each other. Okay, in the next step we will join points O and L together by a straight line. By joining points O and L together by a straight line, we divided the big length into two parts. We will calculate the area of each part, we will add the two areas together, and this will give us the area of this big length. Very simple. So first of all, we will calculate the area of the upper circular segment OL. So I can write down here that our mission is to find out the area of this big length. We want to find out the area of the big length. And first of all, we'll find out the area of the upper circular segment of the big lens that is actually ML, the green shape. Okay? What is the area of the upper circular segment OL? It is actually circular segment OL. The area of the upper circular segment OL this is the upper circular segment OL. So the area of the upper circular segment OL, it is very easy to see from the drawing that is equal to sector NOL, this sector, this is sector NOL that I copied from the original drawing, minus the area of triangle NOL. Minus the area of triangle NOL. Actually, it is very easy to see from the drawing that if you subtract the area of triangle NOL from the area of sector NOL, you will get exactly the area of the upper circular segment OL. Okay, and we have already found out that the angle between the legs of sector NOL is equal to 2 theta. So the area of sector NOL will be equal to 2 theta over 2 pi times the area of the circle, that is pi r square, and r equals to 10, so it is pi 10 square. So here we have pi in the numerator and pi in the denominator, so pi will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So in conclusion, we got that the area of sector NOL equals to 10 squared, that is 100 theta. And we have to subtract from it the area of this triangle, triangle NOL. The area of triangle NOL equals to NL times NO times sinus 2 theta over 2. NL is 10 and O is 10, so it is 10 times 10 times sinus 2 theta over 2. So the area of the upper circular segment OL of the big lens, it is equal to 100 times theta. Here 10 times 10 is 100, 100 over 2 is 50, so it is minus 50 times sinus 2 theta. Okay. So in conclusion, we found out that the area of the upper circular segment OL equals to 100 times theta minus 50 times sinus 2 theta. So our mission is to find out the value of theta, to find out the value of sinus 2 theta, and we substitute here theta and sinus 2 theta by the values that we will find out from those two expressions. Okay. So in order to find out the values of theta and sinus 2 theta, I will draw the right triangle NOM that contains angle theta, and we will derive the value of theta and sinus 2 theta from the right triangle NOM. Angle NOM equals to 90 degrees. In the right triangle NOM, we know that tangent theta equals to OM over ON. OM equals to 5, ON equals to 10, so tangent theta equals to 5 over 10, that is 1/2, 1/2 is 0.5. So in conclusion, we found out that tangent theta equals to 0.5. We want to find out the value of theta itself, so we'll operate the opposite function of tangents on the result, that is tangents minus 1. We'll operate it on the result, that is 0.5. This will give us the value of theta itself. So in conclusion, we found out that tangents minus 1 of 0.5 equals to theta. In the next step, we will find out the value of sinus 2 theta by the same triangle. So I'll copy the right triangle NOM in this place, and we find out the value of sinus 2 theta. First of all, we'll find out the value of the hypotenuse NM by implementing the Pythagoras theorem on the right triangle NOM. In the right triangle NOM, by PT is the relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, mn squared, the square of the hypotenuse, and m squared equals to the sum of the squares of the perpendiculars. That is to say, it is equal to no squared, that is 10 squared, that is 100, plus om squared, that is 5 squared, that is 25. So in conclusion, we found out that mn squared equals to 100 plus 25 it is 125. We'll take out of this equation, and we found out that mn equals to the square root of 125. 125 is 25 times 5. We take root from it and we get that the square root of 25 is 5, so inside the root we left only with 5. So in conclusion, we found out that the hypotenuse mm and m equals to 5 times square root of 5. Now we find out the value of sinus 2 theta. According to the trigonometric identity, sinus 2 theta equals to 2 times sinus theta cosine theta. So sinus 2 theta equals to 2 times sinus theta. And from this triangle we can see that sinus theta equals to OM over MN. OM is 5, MN is 5 times square root of 5. In conclusion, we found out that sinus theta equals to 5 over 5 times square root of 5 times cosine theta. From this triangle we can see that cosine theta equals to NO over NN. NO is 10 and NM is 5 times square root of 5. So in conclusion, we found out that cosine theta equals to 10 over 5 times square root of 5. Here we have 5 in the numerator and 5 in the denominator, so 5 will get cancelled. So in the numerator we have 2 times 10. In the denominator we have square root of 5 times square root of 5 is 5. So this 5 times 5. Here 10 over 5 is 2. So in conclusion we found out that sinus 2 theta equals to 2 times 2 over 5. 2 times 2 is 4, so it is 4 over 5. In conclusion, we found out that sinus 2 theta equals to 4/5. Okay. So I copy again the things that we already found out. We found out that tangents minus 1 of 0.5 equals to theta, and we already found out that sinus 2 theta equals to 4/5. And we have already found out that the area of the upper circular segment of the big lens OL, it is equal to (100 times theta minus 50 times sinus 2 theta. Now we'll substitute theta by tangents minus 1 of 0.5 and we'll substitute sinus 2 theta by 4/5. Do it now and we'll get that the area of the upper circular segment OL, it is equal to 100 times theta, and theta is tangents minus 1 of 0.5, so it is 100 times tangents minus 1 of 0.5 minus 50 times sinus 2 theta, and sinus 2 theta equals to 4/5, so we substitute sinus 2 theta by 4/5, and we get that the area of circular segment OL, the upper circular segment OL, it is equal to 100 times tangents minus 1 of 0.5 minus 50 over 5 is 10, and 10 times 4 is 40, so it is minus 40. So in total we found out that the area of the upper circular segment NL of the big lens equals to 100 times minus 1 of 0.5 minus 40. So in the next step, we'll find out the lower circular segment of the big lens. Okay? So we'll find out the area of the green shape, that is the lower circular segment of the big lens. This green shape. Okay? So this angle equals to 90 degrees. So if you focus on the right triangle NOM, this angle equals to theta, this angle equals to 90 degrees, so this angle must be equal to 90 degrees minus theta, in terms of radians is pi over 2 minus theta. Likewise, so write down that our mission is to find out the lower circular segment of the big lens. The shape in the green color. So we found out that this angle equals to pi over 2 minus theta. Likewise, this angle equals to theta. This angle equals to 90 degrees, that is pi over 2. Therefore, this angle must be equal to pi over 2 minus theta. In order to complete the sum of the angles in this right angle to 180 degrees, this angle must be equal to pi over 2 minus theta. So angle OML equals to the sum of those two angles, that is to say, it is equal to pi over 2 minus theta plus pi over 2 minus theta. So here pi over 2 plus pi over 2 is pi, and minus theta plus minus theta is minus 2 theta. So in conclusion, found out that this angle OML equals to pi minus 2 theta. Okay, it is equal to pi minus 2 theta. So what is the area of the lower circular segment OM? The area of the lower circular segment OM equals to the area of sector MOL, this sector, this is sector OML. We have already found out that the angle between the legs of sector MOL equals to pi minus 2 theta. OM equals to 5, ML equals to 5, minus the area of triangle OML. Minus the area of triangle OML. The angle between the sides is pi minus 2 theta. So the area of sector OML will be equal to pi minus 2 theta. This is circular segment OL. So it is the area of sector OML equals to pi minus 2 theta over 2 pi times the area of the circle, that is pi r square, and r equals to 5, so it is pi square. Pi square. Here we have pi in the numerator and pi in the denominator, so pi will get cancelled. So it is here 25 pi, we'll open the brackets here, it is 25 pi over 2 minus 2 theta times 25 over 2. We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So in conclusion, the area of sector OML equals to 25 over 2 is 12.5. So this expression in total equals to 12.5 pi. Minus 25 theta. And we have to subtract from the area of sector MOL the area of triangle MOL, that it will be equal to 5 times 5 times the sinus, the angle between the sides is pi minus 2 theta over 2. So in conclusion, we found out that the area of the lower circular segment OL of the big lens equals to 12.5 pi minus 25 theta. Here we have minus 5 times 5 is minus 25 over 2, and sinus pi minus 2 theta equals to sinus 2 theta. So we got that the area of the lower circular segment OL equals to 12.5 pi minus 25 theta, but theta equals to tangents minus 1 of 0.5. And we have here minus 25 over 2, and sinus 2 theta equals to 4/5, so we substitute sinus 2 theta by 4/5, and we get that here we have 25 over 5 is 5, and 4 over 2 is 2. And 5 times 2 is 10. So this expression equals to in total to minus 10. In conclusion, the area of the lower circular segment OL equals to 12.5 pi minus 25 tangents minus 1 of 0.5 minus 10. Okay. This is the area of the lower circular segment OL of the big lens. Now we will add the two areas together. We will add the area of the upper circular segment to the area of the lower circular segment of the big lens. And this will give us the area of the big lens in total. So the area of the big lens equals to the area of the upper circular segment plus the area of the lower circular segment of the big lens. Okay. The area of the big lens equals to the area of the upper circular segment OL plus the area of the lower circular segment OL. Repeat again, the area of the big lens equals to the area of the upper circular segment plus the area of the lower circular segment. We have already found out that the area of the upper circular segment of the big lens equals to 100 times tangents minus 1 of 0.5 minus 40, and the area of the lower circular segment of the big lens equals to 12.5 pi minus 25 times tangents minus 1 of 0.5 minus 10. In conclusion, we found out that the area of the big lens equals to 100 times tangents minus 1 of 0.5 minus 25 times tangents 1 of 0.5 is 75 times tangents minus 1 of 0.5 minus 40 plus minus 10 is minus 50, and we have also to add 12.5 pi. So this is the area of the big lens, and we have already found out that the area of the blue lens equal to 12.5 pi minus 25, so we'll subtract the two areas from each other. This will give us the area of the orange shape. Okay, so the area of the orange shape equals to the area of the big lens minus the area of the blue lens. That is to say, the area of the orange shape equals to the area of the big lens, and we already found out that the area of the big lens equals to 75 times tangents minus 1 of 0.5 minus 50 plus 12.5 pi, and we have to subtract from it the area of the blue lens, that is 12.5 pi minus 25. So here we have to we will open the brackets here, and we'll get that the area of the orange shape equals to 75 times tangent minus 1 of 0.5 minus 50 plus 12.5 pi. So we'll open the brackets here, and this expression will be equal to minus 12.5 pi. So here we have minus and minus is plus, so it is minus 25 is plus 25. So here we have 12.5 pi minus 12.5 pi is 0, and minus 50 plus 25 is minus 25. So in total we found that the area of the orange shape equals to 75 times tangent minus 1 of 0.5 minus 25. So, and we know that tangent minus 1 of 0.5 equals to 0.46. Now we substitute tangent minus 1 of 0.5 by 0.46, and we'll get that here it is 75 times tangent minus 1 of 0.5 is 0.46 times minus 25. 75 times 0.46 is 34.77 minus 25. 34.77 minus 25 equals to 9.77 square units. So we actually found out that the area of the orange shape, according to the second method, it is equal to 9.77 square units. Okay? So in the next step I will summarize the lecture. We'll start with the first method. So in the first method, here we have a quarter circle, we have this square ABCD, one side of square ABCD equals to 10 units, and inside square ABCD we have two semicircles that intersect with each other, and they create the blue lens. And in addition we have also the quarter circle that intersects with this semicircle and creates the blue lens. And our mission is to find out the area of this orange shape. The area of this orange shape equals to the area of the big lens minus the area of the blue lens. So here I presented to you two new concepts. What is the area of this sector? The area of this sector equals to the ratio between angle theta to 2 pi radians, that is 360 degrees. So that ratio will give us the relative percentage that this sector occupy out the entire circle, and when we will multiply this percentage by the area of the entire circle, that is pi r square, it will give us the area of this sector. So theta over 2 pi times pi r square equals to the area of this sector in the green color. Then I presented to you the concept of the area of the circular segment AB. The area of circular segment AB equals to the area of sector AOB minus the area of triangle AOB. Again, the area of sector AOB minus the area of triangle AOB equals to the area of this circular segment AB in the green color. Okay, then we actually, again, the area of the orange shape equals to the area of the big lens minus the area of the blue lens. The area of the big lens minus the area of the blue lens. So here we took actually we took two semicircles that intersect with each other. Those are two semicircles that intersect with each other. They are perpendicular to each other. And the common area of those two semicircles is defined as the length. And we want to find out the area of this length. So this length could be the area, the blue lens. This length could be the blue lens that was created from the intersection of those two semicircles with each other, and it could be also the big lens that was created by the intersection of those this quarter circle with this semicircle. And because of the fact that they are perpendicular to each other, it is also could be this big lens. Okay, and because of the fact that the radii of those two semicircles, they are A and B, they could be any positive number, and especially here A could be equal to 10 units and B could be equal to 5 units, and this will give us exactly the big length. While if A equals to 5 units and B equals to 5 units, then those are two identical semicircles that intersect with each other. They are perpendicular to each other, and the intersection of those two semicircles with each other will give us the blue semicircle. So by finding out the formula for this semicircle, we can use it in order to find out the area of this big semicircle and also the area of this blue big lens, and also the area of this blue lens. Okay, so here we actually define the radius of this semicircle as A, the radius of this semicircle as B, and then we join points M and L together by a straight line. So we divided this length into two parts. We found out the area of each part, we added the two areas together. This is the sum is the area of this length in total. Okay, so first of all we found the area of this circular segment, the green circular segment. what is the area of the green circular segment? It is equal to the area of sector MOL minus the area of triangle MOL. Okay. Then we found the area of the lower circular segment. The area of the lower circular segment equals to the area of sector MNL minus the area of triangle MNL. Okay. Then we added the two areas together. This will give us the area of this length. Here, the sum of the areas of those two circular segments, the green circular segment and the orange circular segments, give us the area of this circular of this length in total. So this is the area of the green circular segment plus the area of the lower circular segment. It is equal to the sum of the areas of the two sectors minus the area of the two triangles, because they are in negative sign here, and we have already found out the areas of those two sectors. This is this expression minus the area of the two triangles. In order to find out the area of those two triangles, we combined them together, and then we added we joined points and O together by a straight line. In this, we actually joined points yes N and O together by a straight line. In this way, we created two right triangles. The area of the green right triangle equals to A times B over 2. The area of the orange right triangle equals to A times B over 2, and the sum of the areas is A times B. So we have to subtract from this expression A minus B. This is the sum of the areas of those two triangles. So in total, we found out that the area of this length equals to this expression. Then we took theta as a current factor, and here we have this expression, and we want to eliminate theta, so I draw triangle OMN, the right triangle, that this is a right triangle. This angle equals to 90 degrees. That contains angle theta. Therefore, here we can see that tangent theta equals to MN over MO. MN equals to B, MO equals to A. So in total, tangent theta equals to B over A. In order to find out the value of theta itself, we operated the opposite function of tangents on the result, that is B over A, and we got the value of theta. Then we substituted theta by tangent minus 1 of B over A, and we found out that the area of the length that could be the blue length or the big length equals to tangent minus 1 of B over A times A square minus B square plus pi B square over 2 minus AB. So then we found out the area of this big length. Here we know that the radius of the quarter circle equals to 10 units, while the radius of this semicircle equals to, we know that the diameter equals to 10, therefore the radius equals to 5. So A equals to 10, B equals to 5. We actually put the values of A and B inside this formula, and found out that the area of the big length equals to 75 times tangent minus 1 of 0.5 plus 12.5 pi minus 50. Okay, then here the blue length is created by intersection of those two semicircles with each other. The common area, it is the blue lens actually. And we know that the radius of each semicircle equals to 5, because here the diameter is 10, therefore the radius is 5. The diameter is 10, here it's 10, so the radius is 5. So A equals to B equals to 5. So we put the value of A and B inside this formula. It is good for the for finding out the area of the big lens, and it is also good for finding out the area of the blue lens, and also for all the two shapes that are perpendicular to each other. So here we found out that the area of the blue lens equals to 12.5 pi minus 25. And we know that the area of the orange shape equals to the area of the big lens minus the area of the blue lens. I'll repeat again, the area of the orange shape equals to the area of the big lens minus the area of the blue lens. This is the expression for the area of the big lens, this is the expression for the area of the blue lens. We subtracted the two areas from each other and we got in conclusion that the area of the big lens and the area of the orange lens, the area of the orange shape, this shape, the QP, equals to 9.77 square units. So finished with the first method. Then I presented to you the second method. In the second method, we didn't create a general formula for the area of a lens, but we directly calculated the area of the blue lens, we calculated the area of the big lens, we subtracted the two areas from each other, and the result is the area of this orange shape. So first of all, we calculated the area of the blue lens. Here, the area of this blue lens was created by the intersection of the two semicircles with each other. The common area is the blue lens. Here we know that the radius of each semicircle is 5 units, and they are perpendicular to each other, so this circle equals to 90 degrees. The radius is 5. So we found out, and because of the fact that the two semicircles are identical, when you draw perpendicular to the diameter, it will be also tangent to the other semicircle at point L. The same thing is true for this semicircle. When you draw a radius that is perpendicular to the diameter, it will be also tangent to the other semicircle at point L. So here we have square LO and S, and when we join points N and L together by a straight line, it divides the blue lens into two equal parts. So we'll multiply the area of this circular segment by 2, and this will give us the area of the blue lens. I repeat again that the area of the circular segment NL equals to the area of sector NNO or NOL minus the area of triangle NOL. is equal to the area of triangle it is equal to the area of sector NOL minus the area of triangle NOL. But because of the fact that this angle equals to 90 degrees, it means the sector NOL it is actually a quarter circle. And you know that the area of any quarter circle equals to the area of the circle over 4, and the radius is 5. So the area of the circle is pi r squared, r equals to 5, so it is pi 5 squared. And then when we divide the area of the circle by 4, we get the area of this quarter circle. So the area of this quarter circle NOL equals to pi 5 squared over 4. Well, the area of this right triangle equals to the base of the triangle times the height to the base over 2. This 5 times 5 over 2. So this expression equals to the area of this circular segment. We multiply this area by 2 and we get the area of the blue lens. In conclusion, we found out that the area of the blue lens equals to 12.5 pi minus 25. We finished with the blue lens. Now we find out the area of the big lens. Okay, the area of this big lens. Actually, the big lens is created by the intersection of the quarter circle with this semicircle. The common area is defined as the big lens. Here, the intersection of this quarter circle with this semicircle created this big lens. Actually, we divided the big lens into two parts, and we calculated the area of each part. We added the two areas together, and this gave us the area of the big lens. Because of the fact that this semicircle is perpendicular to the quarter circle, it means that this angle equals to 90 degrees. Here we have the radius NL that is drawn to the point of tendency. That is to say, it is drawn to point L, that is the point of tendency of tangent ML with this quarter circle. And whenever we have a radius that is drawn to the point of tendency, then tangent ML will be perpendicular to the radius Ln. So if ML is perpendicular to Ln, it means that this angle equals to 90 degrees. Okay, actually, those two triangles can go into each other according to side rule. Therefore, those two angles are equal to each other. So if this angle equals to theta, then this angle must be also equal to theta. Okay? Then we calculated the area of circular segment, upper circular segment of this big lens. The area of this upper circular segment of the big lens will be equal to the area of sector NOL minus the area of triangle NOL. I'll repeat again. The area of circular segment OL equals to the area of sector ONL minus the area of triangle NOL. Okay? And we found out that the area of the upper circular segment equals to 100 times theta minus 50 times sinus 2 theta. Then we found out the area, the value of sinus 2 theta and the value of theta itself by analyzing the triangle NOM. Okay, here in this triangle NOM we have angle theta, and it is a right triangle. So here it is very easy to see that triangle theta equals to 5 over 10, that is 0.5. So therefore theta itself will be equal to tangent minus 1 of 0.5. So we found out the value of theta. Then with the same triangle, we found out the value of sinus 2 theta. Here first of all we found out the value of the hypotenuse MN by the Pythagoras theorem. The value equals to 5 times square root of 5. Then sinus 2 theta equals to 2 times sinus theta cosine theta. And so sinus 2 theta equals to 2 times sinus theta. Sinus theta equals to OM over MN. OM equals to 5. MN equals to 5 times square root of 5. So the value of sinus theta equals to 5 over 5 times square root of 5 times cosine theta. Cosine theta equals to 10 over square root of 5 times square root of 5. Okay, so in conclusion, we found out that sinus 2 theta equals to 4/5. So we found out the value of theta, we found out the value of sinus 2 theta. Now we can substitute we can substitute theta by 10 raised to minus 1 of 0.5, and we can substitute sinus 2 theta by 4/5. We did it, and in conclusion found out that the area of the upper circular segment of the big lens equals to 100 times 10 raised to minus 1 of 0.5 minus 40. So we finished with the upper circular segment of the big lens. Then we found out that the area of the lower circular segment, we found out the area of the lower circular segment of the big lens. Found out the area of this shape, that is the lower circular segment of the big lens. Okay? What is the area of the lower circular segment of the big lens? It is equal to the area of sector LMO minus the area of triangle LMO. And repeat again, the area of the lower circular segment OL of the big lens equals to the area of sector OML minus the area of triangle OML. Okay? So we did the calculation here, and we found out that the area of the lower circular segment of the big lens equals to 12.5 pi minus 25 times 10 raised to minus 1 of 0.5 minus 10. Then we added the two areas together, that is to say, we added the upper circular segment of the big lens to the lower circular segment of the big lens, and this gave us the area of the big lens in total. I repeat again. We added the area of the upper circular segment of the big lens to the area of the lower circular segment of the big lens, and this gave us the area of the big lens in total. So we found out that the area of the big lens equals to 75 times 10 raised to minus 1 of 0.5 minus 50 plus 12.5 pi. And we have already found out that the area of the blue lens equals to 12.5 pi minus 25. Now we know that the area of the orange shape equals to the area of the big lens minus the area of the blue lens. Okay? Repeat again. We know that the area of the orange shape equals to the area of the big lens minus the area of the blue lens. So the area of the big lens equals to this expression. The area of the blue lens equals to this expression. We subtracted the two areas together from each other, and we found out that the area of the orange shape, the area of this orange shape equals to 9.77 square units. This equals to 9.77 square units. In both methods we arrived to the same result, that the area of this orange shape equals to 9.77 square units. Okay? So I'll summarize again what we did in this lecture. We found out the area of this orange shape in two different methods. In the first method, Anyway, one thing is true in both methods, that the area of this orange shape equals to the area of the big lens minus the area of the blue lens. But in the first method, we found a formula for the area that could be the area of the blue lens and also the area of the big lens. So it is a general formula for, that we can use for two shapes that are perpendicular to each other, and they create the lens when they are perpendicular to each other, exactly like in this drawing. Those two semicircles are perpendicular to each other, and they create the blue lens, and here the quarter circle is perpendicular to this semicircle, and in this way they create the big lens. So we found out the general formula that is good for the two shapes that are perpendicular to each other, and this way they create the lenses. So the formula that we created was good for to find out the area of the blue lens that was created by those two semicircles that are perpendicular to each other, and it was good also for the big lens that was created by the intersection of the quarter circle with this semicircle, and we know that they are also perpendicular to each other because this angle equals to 90 degrees. So in the first method, that we created a formula that is good for two shapes that intersect with each other, and in this way they create the lens. While in the second method, we found out directly the area of this big lens, then we found out directly the area of this blue lens. We subtracted the two areas together. In this way, we found out the area of this orange shape that is equal to 9.77 in both methods. Okay, so while in the first method we found a general formula for two shapes that are perpendicular to each other, and that is the way they created the lenses. In the second method, we directly calculated the area of the blue lens, we directly calculated the area of the big lens, we subtracted the two areas from each other, and in this way we got the area of the orange shape. Okay, so that is the difference between the first method to the second method. Okay, thank you very much.